Hello everyone. Today we are going to discuss about multivibrators. Is in your fourth unit. So, what does mean by multivibrator? First, it is an electronic switch, electronic circuit, which used to produce clock signals, square pulses, and timing circuits for the digital circuit. So, used in the digital circuit. So normally it consists of it are classified into three types. One is astable, bistable, and then monostable. So today we are going to see about in detail astable multivibrator. Before enter into the session, first we have to recall that last session we are discussed about the feedbacks, positive feedback, negative feedback, uh, all the informations were discussed. So what is regenerative feedback? Yes, it is a part of output is given to the input in phase, and based on this, we are increasing the output or amplifying the output. That we call as the regenerative feedback. What is the switching circuit? It is a normal switching like on and off. And what does mean by oscillation? It is an oscillation. Oscillation means the signals produced continuously. And the pulse generator's importance is to given for the digital, wherever you're using digital, we need a pulses. Then we are using pulse generations. And topics today we are going to discuss introduction to multivibrators, astable, and the waveforms of timing and analysis applications in industry sector. So let me explore. First, we have to discuss about the constructions. What are the points we have to keep in your mind? First thing, we are using two transistors called as an identical transistors. Identical transistors means we can use both are NPN or PNP. So see in the diagram, both are NPN transistors. So both transistors are coupled each other in the cross coupled form. What is meant by cross coupled form? The base of the transistor is given to the output, and other transistor base is given to the other outputs. Likewise, collector output of the one transistor is given to the base of other transistors. Likewise, for the second transistor, collector output is given to the base of other transistor. So this is we called as the cross coupled transistors. And normally the capacitor value and resistor values are equal. Now capacitor values, the capacitor is used to regenerative feedback. It produces the regenerative feedback. And for charging the capacitors through the resistors R1, R2, R3, and then R4. So these are the point you have to keep in mind. Along with the output 1 and 2 have to show that there is a waveform is appear in your circuit. The output 1 waveform is in negative form and output 2 is in the positive form. That is on state to off state. Here the off state to on state. So both are opposite each other. That is by here the output is positive, output of 1 is negative. So on this point you have to keep in mind for the construction. For the working, the same diagram here we are considering. Let's assume we are giving the supply to this circuit. So both transistors are tried to on, but based on the value of minimum difference between the value of base value, any one of the transistor will get turned on and other will get turned off. So normally in this astable, always one transistor is in on condition and another transistor is in off condition. So consider the Q1 will be in on condition. That is here we are mentioning TR1 transistor 1, TR2 transistor 2. So TR will be in on condition and TR2 is in off condition. So on condition means it is the closed switch. Off condition means is in the cut off region or the open circuit. So if in the on circuit, the collector output of the TR1 is low. That value is given through the C1 to the base of TR2. So always the base value is low in transistor will cut off region. That is in off condition. When the transistor is in off condition, the collector of that particular transistor, that is here we are considering TR2, collector output is high. The high value is given through C2 to the base of TR1. So after some time, the collector value of C2 will charge through R3, and once it reaches the value of more than the threshold value, that is a particular or specific value that we call as cutoff region or specific value, this we call as the 0.7. Here we consider 0.7 volt. So when it reaches the 0.7 volt, then is given to the base of Q1. Always the Q1 now is in the collector of this low, so the C1 will charge through R2 when it reaches the 0.7 and is given to the base of TR2. It will get turned on. Automatically the TR1 will be turned off. So for turn on and off, the capacitor C1 and C2 will produce the value to the base of TR1 and TR2. Based on the value of TR1 and TR2 base values, the transistor will get turn on and turn off automatically based on the value of capacitors and along with the resistors value. So this is the waveform, and here it shows the VC1 is in off condition. It is here the Q1 is on, Q2 is off. The Q1 is in on condition, the Q2 is in the off condition, and the Q1 is off, Q2 is on. So likewise, the clock generated square pulse will be created on both outputs. And normally frequency oscillation is F is equal to 1 by T. T is based on the RLC value. And the advantage is external trigger is not required, and circuit is simple, inexpensive, and it will function continuously. And disadvantages of this Astable is the energy absorption is more within the circuit, output signal is low, and duty cycle is less than or equal to 50% can be achieved. And this is the define and the empathy of Astable. And real world application is here using timer circuit, analog circuit, TV systems, and code generators and radio equipments also we are using. And summarization, here we are mentioning the references. So thank you all. See you in the next session.